Hi, today we're going to talk about the lymphatic system. My name is Claudia Brianna, so let's talk about the primary functions of the lymphatic system. We have three primary functions of this system. The first one is that it aids the immune system in removing and destroying waste, debris, red blood cells, pathogens, toxins, and cancer cells. We're going to see a video explaining us how it takes place. So let's listen about it. So what we have here for the first video.
The heart pumps blood throughout the body, and it pumps so powerfully that it actually squeezes some fluid out of the capillaries. And that fluid becomes lymph, and it's the lymphatic system that gathers all that fluid and brings it back into circulation. But this idea might bother you. You might have an objection, which is these lymph vessels don't have a heart of their own. I didn't draw one, and it's because they don't have one. So how is it that they're able to pump this fluid in one direction? And moreover, how is it that they're able to pump it back into this high pressure system? Given that they don't have a pump, that must be quite difficult. There are two answers to this question, really, and the first is a little simpler, so let's start there. The first answer is essentially in the location of re-entry. So the reason why lymph is able to get back into the high pressure system is because lymph is quite intelligent about where it tries to re-enter the high pressure system. So I'm drawing a star here because that's where the lymph re-enters. I didn't draw that by accident. It re-enters at the very end of the venous circulation system. And the pressure there is much lower than the pressure in the arteries and even the pressure in the capillaries. The numbers are actually pretty striking. The pressure here in the early arteries can be about 120 millimeters of mercury. That's kind of like your average blood pressure. But over here, just before it enters the heart, the pressure is more like 5 millimeters of mercury.
So here we have absorbed fats and fat-soluble vitamins from the digestive system, and the liver sends nutrients to the cell of the body where they are used by the cells. This is the second function of the lymphatic system. Let's see a video that could explain us about this and how it takes place, how the lymphatic system absorbs the fats in the intestines, in the small intestine. We're having some problems with the video. It's now playing. Playing. Nope. No video. Sorry. Let's go to the third function of this system. It also removes the excess fluid and waste products from the interstitial spaces between the cells. We have here that the lymph is a clear, colorless fluid containing white blood cells that helps the body get rid of toxins, waste. And let's see what is the lymphatic system. What's the role of the lymphatic system here in our immune system? So let's see what the video has to tell us. So here we have, and let's listen what it has for us.
We've talked about how the purpose of the lymphatic system is to collect fluid that's squeezed out of blood vessels like this one, to collect that fluid and eventually bring it back into the blood so that we don't lose too much fluid. So this is a blood vessel. Around it we have some cells that are maybe being fed by that blood vessel. And at the same time we have these lymphatic kind of start out of nothing, and they're porous so that they can collect the fluid that was squeezed out of the blood vessels, and then eventually they'll put that fluid back into the blood. But the lymphatic system actually has other purposes. It helps us in other ways, and we're going to talk about one of those other ways in this video. And to talk about that, we need to talk a little bit about infection. So infection is when your body gets attacked by a foreign invader, and that invader will usually be a bacteria or a virus. And in this case, let's talk about a bacteria. So let's say we get a bacteria that invades this tissue here. So the first thing you might ask is, why am I drawing the bacteria here? Why am I drawing it outside of the blood? Maybe I should be drawing it here inside the blood. And one reason why, I might think that, why you might think that, is because think about when you get infected. Sometimes you get infected when you cut yourself, right? When you cut yourself, you might get an infected wound. And when you cut yourself, you see blood. So you might think that you're getting infected because bacteria or viruses or whatever are getting into the blood. But actually, that's not quite true. Infections are usually not in the blood. And actually, there's a pretty simple, you could say, proof of that, which is that when you get infected, infections almost always stay localized. And by that, I mean that they usually stay in one place. So think about when you get an infected cut, usually, let's say it's on your finger, the infection will stay on your finger. Or let's say you get a UTI, which is a urinary tract infection. The infection usually stays in your urinary tract. Or maybe you get pneumonia, the infection stays in your lungs. So if the infection was actually in your blood, it would immediately go all over the body. And that does happen sometimes, but it's way more serious than the majority of infections. So really the most accurate way to draw a typical infection is to draw the infection occurring in the tissues. Now when we have this infection, there are going to be some local immune cells that your body has that's going to be fighting these bacteria and trying to kill them. But your body also has more powerful defenses, which consist of B cells and T cells. And these guys are part of the adaptive immune system, which means that they actually sort of react to the specific invader that's there. So unlike these guys here, which for the most part are macrophages, unlike these macrophages who can fight, lots of different kinds of bacteria, these B cells and T cells will react to the specific bacteria and end up having a much more powerful effect against them because of that. They're specially tailored to the invader. But the problem is that these guys don't just sit out there in the tissues where the infections start. And there are a few reasons for that, but probably the most.
And now we're going to talk about the parts of the lymphatic system. We have the lymphatic nodes. The lymphatic nodes are so soft, small, and round, and they have a bean-shaped structure. They are usually cannot seen easily, and they are located in the cluster of various parts of our body. We have them in the neck, armpit, and we also have other organs from the lymphatic system. We have the tonsils, the thymus, the lymphatic nodes, the lymphatic vessels, the liver, the spleen, the appendix, the bone marrow, and the pericarp in the small intestine. Also, we have another video that could explain us and resume us what we have in our class, or what we can have from the class from this video. So let's see what the video has for us.
So we've talked a lot about the lymphatic system, and in this video I wanted to talk more about lymph, which is the fluid that's in the lymphatic system. So we know that lymph comes from blood vessels originally. It's the fluid that's kind of squeezed out of vessels. And so here, let's say this is a capillary. I'm drawing the endothelial cells around the capillary. So lymph is what comes out of here, what's squeezed out through the little holes between the capillaries. And just so we have our terminology straight, really lymph is only called lymph once it gets into the lymphatic vessels. So once this fluid gets into here, now we can actually call it lymph. But before it does, it has more, it's more called extracellular fluid. because it's outside the cells that are out here. But really the composition is the same, and so this is just a semantics thing. But so in this video, let's try to figure out exactly what lymph is made of. And so to do that, let's start with blood, because lymph originally comes from there. So in blood, we obviously have red blood cells. So let's draw a couple of those in here. These are red blood cells. And in reality, we should draw more than a couple, because we know that blood is actually consisting of about 40 or maybe even 45% red blood cells, 45% by volume. And that's in the average person. If you're anemic, it'll be less. So blood has about 40%. We were drawing much less than that here, but it's kind of hard to draw them all packed in, so let's leave it like that. And so other than that, of course, we have water, which we'll draw white. This is water. And we also have proteins. We have proteins, and we'll draw those of varying sizes because proteins really do vary by size, and we have many different kinds of proteins in the blood that do many different kinds of things. And that's all that we'll draw here, even though there are also glucose molecules and fats and other things in the blood. We can ignore those for now. So what gets out here? What manages to squeeze through? Well, we know that the red blood cells don't manage to squeeze through, so certainly by the time we get to extracellular fluid, we'll have 0% red blood cells. And so lymph will have no red blood cells. But other than that, let me ask you a question. Do you think that lymph has more protein or less protein than blood? And let's just say by concentration. So it's actually a tough question, because if all the protein came out freely of these vessels, then lymph would actually have a higher concentration of protein than blood, because blood had these red blood cells that were taking up space, and so the protein was, so to speak, diluted by this huge amount of red blood cells. And out here, it won't be diluted by red blood cells. But actually, there's less protein out here in the lymph, and that's because water gets out so much more easily from these capillaries than protein that you end up with fairly dilute fluid here. So proteins have a kind of tough time getting out, and certainly some of them do get out, and so we'll draw those here. But it's much less than are in blood, and so we end up with about a half to a third the amount of protein in lymph compared to blood. So lymph has about a half to a third versus blood. Let's draw that like that.
So
another thing we can ask ourselves is what kinds of proteins are going to be in this lymph. Since we said that there were so many different kinds of proteins in the blood, which ones are going to get into the lymph? And actually,
thank you for watching the video. Bye.